Okay, hello everyone. We are going to do question 2 of experiment 1. So first we share the screen, then we can begin. So question 2 says we should take this open loop transfer function, and then we should use MATLAB to obtain the closed loop transfer function, and then also to plot the unit response curve of the system and get its performance specifications: rise time, settling time, peak overshoot, and peak time. So we start by inputting this into MATLAB in order to get the closed loop transfer function. So I decided to start on the first so you can see how I'm going to be doing it. So first, numerator is 16 and the denominator is, as you can see from the question, we have s squared plus 1.6s plus 0. The 0 is the constant. If you forget the 0, it won't plot the graph, it won't plot the function very well. So here we have 1.6 and 0. So that's it. And then now we need to now bring out our original transfer function. We name it G is equal to transfer function open numerator denominator. So here undefined. Oh, sorry. So at the top they were supposed to write numerator, but we wrote no. So maybe we can just go G cos transfer function open. First is nu, comma. Okay. So our transfer function is printed here. So this is our original transfer function. Now we need to find the closed loop transfer function. But to find the closed loop transfer function, we need to know that it is a unit closed loop transfer function, which means the feedback is 1. So if the feedback is 1, then we can label the feedback 1 as G1. So let's make a comment. Feedback is 1 since it's a unit transfer function. All right, so now we write our closed loop transfer function. So no, sorry, let's label the G1 to be equal to 1. Okay, then now we can write our closed loop transfer function. We shall label our closed loop transfer function. Okay, so let's say closed loop transfer function. So we shall label it CG. So our CG is the closed loop transfer function, which is equal to feedback bracket of G comma G1 comma minus 1, since it's a negative feedback function. So as you can see, this is our closed loop function. We have already generated our closed loop function. Now with this answer is our closed loop transfer. So we copy this answer like this. This is the only answer we need, and then we take the word like that. Okay, then the second part is we should plot the unit step response curve of the system. So first we are going to plot the unit step. To plot the unit step, it is a function of time, so we need to set the time. So we will say, for instance, our time is 0 is to 0 0.1 is to 20 20. Right, so these are the arrays of the points that are going to be used to plot the graph. Then after after writing the time you click enter, the MATLAB will give you this itself. Then after we shall plot the unit step diagram. And the step diagram, you just need to write step, and then input CG, which is our closed loop transfer function, plot it with respect to time. So yes, we click enter and we wait for the diagram to be drawn. Okay, so this is the diagram. It has been drawn, right? Yeah, so the diagram has been drawn. This is it. So now we have the diagram. So we are supposed to now find the rising time, settling time, peak overshoot, peak time. So to do that, um just click on the any blank space, right click on any blank space, go to characteristics, click on peak response. As you can see, this is the peak response. Then characteristics again, settling time. This is the settling time. Characteristics again, rise time. This is the rise time. And then the steady state. This is the steady state. After this, then you click, just left click once here, left click once here, left click. Okay, so you can drag this down to make it better, and then left click once here, left click once here. So after getting this, then we shall go to file, then we will save this figure. In saving, please, you need to select picture format, JPG picture format. You label, maybe save it where you want to save it. Then you can copy that into your file. That is all we want. This is my diagram as I'm showing you. So that is all for experiment 2.
Thank you.